told us to put it out.
Investigators are now convinced that the King's Cross fire was started by a discarded match that ignited dirt-clogged grease. But to prevent a repeat of the disaster, they still have to solve its most fundamental mystery. What transformed the small blaze into a raging inferno in a matter of seconds? Investigators are certain that a small amount of lubricating grease wouldn't be capable of creating such a freakish phenomenon because it burns too slowly. The hunt for the missing factor intensifies. Now investigators consider a theory being talked about in the news. It suggests that a phenomenon unique to underground stations could be to blame. When a train enters an underground platform, it pushes a rush of air ahead of it. It's called the piston effect, and it helps keep the tube system ventilated. Did a high-speed rush of air act like a set of giant bellows on the fire, triggering the flamethrower effect described by witnesses? Investigators examine station logs from the day of the disaster. They need to analyze the movements of trains in and out to build a pattern of air movements up the escalator shaft. In the 10 minutes before the inferno, trains departing underground platforms would have pulled fresh air down the escalator shaft, which wouldn't have had any major effect on the fire. But they discover that at 7:42, just 3 minutes before the fire erupts, everything changes. An eastbound Piccadilly line train pulls in. Seconds later, a westbound train also arrives. The combination of two trains arriving almost simultaneously has a dramatic impact on the airflow. It sends a huge blast of air up the escalator, the same direction the fire traveled. To find out if it offers the key to the disaster, investigators have to calculate if the airflow was traveling fast enough to have a significant effect on the fire. They measure the airflow produced by tube trains and calculate that two trains arriving one after the other would make the airflow up the escalator travel at 11 feet per second. That's only 7.3 miles per hour. Nowhere near fast enough to an escalator drops a lit match. By chance, the match falls through a gap in the wooden steps and lands on the trash-clogged grease of the escalator running track. 7:29 p.m. 16 minutes to catastrophe. As the fire takes hold beneath the escalator, commuter Philip Squire sees the glow. He tells the ticket collector, but when they look from the top, the 30-degree angle hides it from view. 2 minutes to disaster. Firefighters arrive and assess the fire. It should be easy to contain. But what they can't see is that the trench effect is causing gases from the fire to superheat the wooden steps. 20 seconds to go. As passengers step into the ticket hall, the superheated stretch of escalator spontaneously ignites. Disaster strikes. Flames surge up the wooden steps, traveling at 40 feet per second. A jet of fire erupts into the ticket hall with a heat output of 25 megawatts, as much energy as a jumbo jet uses during takeoff.